Hi, I'm Mr. Hoover, and in this video we're going to look at problem 2b. Cosine of x is equal to minus 1/2. Cosine of x is equal to minus 1/2. So minus 1/2, that will be here. So you go up. So we're looking at this arc length here. So this is an agreement between us. If we have an x here, we want to work in radians. Okay, if it was an alpha, we would work in degrees. So now look, this is a number we should know by heart, because look, cosine 1/2 means 60 degrees. But we're at minus 1/2. That means this is minus 60 degrees, or when you look at the table in radians, it is pi thirds. So this wiggly part here is pi thirds. So pi minus pi thirds, that's the red part. So that's 2 pi thirds. So this is 2 pi thirds, this arc length. So x is equal to arc cosine of minus 1/2. Well, let's type this in. Arc cosine of minus 0.5. That's 2 thirds times pi, or 2 pi thirds, same thing. X is 2 pi thirds. But now look, you could produce this line, continue this line down here, and then you notice that this is minus 2 pi thirds. 2 pi thirds minus 2 pi thirds. It's clockwise, this is counterclockwise. Counterclockwise, clockwise. So plus minus 2 thirds. And whenever you're here or here, you add full turns. Well, one full turn in radians is 2 pi. K element of Z. So these are all your solutions that satisfy this equation. If we had done this in degrees, cosine alpha is minus 1/2. We could have done it. Then we would have had alpha is 120 degrees. This would be 120 degrees, and this would be minus 120 degrees. So plus minus 120 degrees plus k times 360 degrees with only full turns. That's why k must be an element of Z. Here we go. This would have been your solution in degrees. But we want to do it in radians now. It's the exact same thing, but it's a bit more unusual. Okay? So I hope it wasn't too difficult. See you on the next one.